All right, so for this video, I wanted to go through kind of an alternative approach to integration by parts. So the first video went through pretty much sticking with Leibniz notation, with the whole U and isolate du, take dv, integrate it to find out what v is. Uh, if we think of this using more of Newton's notation, where because I'm undoing product rule, I'm going to have the integral of f, some function f times a function g. And the way I decide what f is something that, like I do with u in Leibniz notation, that if I keep differentiating it, I eventually get down to zero. And then g of x is the parts that's left, but what I'm going to do here is instead of differentiating, I want to integrate it. And this is something that should be integrated easily over and over again. And we can make a table for this to help us figure it out. So if I'm looking at the integral of x squared e to the x, like the last example where we had to do integration by parts several times, and this is a method that works well for that. Well, x squared, if I keep taking its derivative, eventually goes down to zero, whereas e to the x, I can integrate it over and over and over again. It's always going to be e to the x. But if I were to differentiate it, it would not go towards zero. It would always stay e to the x still. So in one column, I'm going to take f of x and do its derivatives until I get down to zero. So I would start with x squared, its derivative is 2x, derivative of that is 2, and the derivative of that is 0. And I just keep taking it down until I get to 0. Then I would take g of x, which is the part that's left. Oops, keep my colors consistent here. And I would integrate it. So I'm not deriving, I'm integrating. Antiderivative of e to the x is e to the x. Antiderivative of this e to the x is e to the x. Antiderivative of this e to the x is e to the x. Okay. And what I'm going to do is I'm going to start drawing diagonals. So I start here with the first f of x, and I draw it down to the second g of x. And what this arrow is saying is I'm going to multiply these two things, and I start with a positive. So my first term is going to be a positive x squared e to the x. Well then, next, I take the second f of x term, go diagonal to the third g of x term, and this is going to be a minus. So I multiply what's connected by the arrow and subtract it, so this is going to be a negative 2x e to the x. Then go to the next one. Again, diagonal from the third f of x term to the fourth g of x term, and this is going to be positive. So this will be plus 2 e to the x. And then when I get to the next term, I stopped here because it's going to be 0 times something, so it's 0. And I can stop there and put my plus c. And if you notice, this is what we got on the last when we did this using u substitution, or not u substitution, integration by parts multiple times. So this is a way that if I'm going to have to do integration by parts several times, this tends to be a faster way. The key is, first column is f and its derivatives, second column is g and its integrals. I multiply diagonally, and I alternate starting with plus, minus, plus, and then I keep going minus, plus, minus, plus, minus, plus, minus, as far as I need until I got down to where everything would be 0. And here is our antiderivative.